Hello class, welcome to our lesson for today dealing with adding integers. This is from section 1.2 in your textbook. Today we're going to be looking at kind of the beginning piece of the lesson. So I'm trying to correlate kind of what we're talking about to at least what's in the book. So what you'll probably notice is a lot of the pieces from today's lesson are in the first couple pages of section 1.2. The plan is going to be in general, not every section, but in general we're going to spend about 2 days on each section. That allows everyone to get up to speed and make sure they understand what's going on. I think that'll be helpful for you as we keep moving through the semester to make sure that you understand these topics as we move throughout the year. So let's get started with adding integers. You'll notice that there's 6 questions here that deal with adding integers. Now you've dealt with questions like these before. Notice all of these numbers here are positive. And if all integers were adding positives, you probably wouldn't have to talk much about them with me or in 7th grade math in general. All of these questions here are just adding up a bunch of positive numbers, and you could probably do that on your own. So if I said, oh, there's going to be a test on adding these types of questions, you'd probably say, that sounds great. I can do that. Add some numbers, move and carry the numbers over to the next column if you need to. Make sure you're okay on these 6 scenarios. Okay, about how to find those answers without a calculator. Obviously, with a calculator should be no problem. Okay, but make sure you understand how to find those answers as you're going through it. Okay, today we're going to focus on some visual representation of integers because not everyone thinks about math in the same way. So if you're more of a number person, you probably won't be using the strategy as much. But if you're a visual learner, my hope is that this will help you understand how integers work. So this first question says to take -4 plus -3. -4, I'm going to represent, notice here I have a circle, these are called integer counters with a minus sign in them. So -4 has 4 of them, and -3 has 3 of them. And if I add them together, essentially think of it like there's a pile of 4 and a pile of 3, and just put them together. And if that's the case, then there's going to be 7 of them. And there's just 7 of those negative integer counters. That'd be no different if you were playing a specific game and it was like the blue counters, add up all the blue ones, or in this case the red counters, add up all the red counters. And so what you'll notice here is that -4 and -3, -4 and -3 will end up equaling -7 for that reason. The next one says take -3 plus 2. Now I tried to kind of differentiate between the two, so you've got the 3 negatives with a minus sign in the middle, and 2 positives with a plus sign in the middle. But notice when you put these together, they're not all one group. Okay, there's some of the negative group and some of the positive group. And what happens is the negatives and positives cancel each other out. So what you'll notice here is that my 2 negatives and 2 positives kind of duke it out, so to say. You can think of like they're jousting or something, if that makes sense to you, and they both hit each other off their horse and they're gone. Okay, but what's left is, oh, there's an extra negative that's left because there were more negatives than there were positives. So really, this is not necessarily an addition problem. It's really a subtraction problem as you're looking at this scenario. And the answer will be -1. So -3 plus 2, notice you're really not adding them together, you're subtracting them, and that's the key part of the question. Another way to look at something visually is through a number line. So I decided to do this one with a number line, show how the number line finds 5 plus -3. All numbers kind of start at the 0 location. They hinge from there. And plus 5 would move 5 forward. Okay. On a number line, moving to the right is going forward and positive, and moving to the left is going backwards or negative. So I go plus 5, and then I go back 3, and that will leave me at the number 2. With the integer counters, what you're saying is there's 5 positive ones, 3 negative ones. They go at each other, kind of fighting, okay, so to say. The 3's cancel out, and you're left with 2 of them, but they have to be the positive group because the positive number had the 5 originally. So there's 2 left of that situation. Okay, so when you're dealing with it, it's kind of which one has the upper edge, and it's strictly a numbers game at that point. Okay, so now the important thing is how can we figure out if something's positive, if something's negative, or something's 0? Many of you have had thoughts just by looking at the few examples that we've had here today so far. So let's think about all of those situations and how we can figure out if integers will add up to be a positive, negative, or 0. This information, it can be written in a lot of different ways. I'm just trying to give the basic info. What might be helpful is taking some notes from this slide, for example. Many of you are doing the right things in terms of notes. If you haven't been doing that, you want to make sure that you start doing that. It helps you stay engaged with the video and also engaged with the lesson itself. Okay, when I say two integers with the same sign, what I'm saying is two positives or two negatives. The rules are the same for these two situations. You add them up, so 4 plus 5 is 9. Or in the second one, I kind of ignore the negative signs. Negative 4 and negative 5, I just add 4 plus 5 and it's 9. But then I have to know that the label is negative because those are like the negative integer counters. If they have different signs, what we mean by that is one negative, one positive. And that's when we actually do subtraction, not addition. And so the question is, which one's larger? So if the positive is larger, you're going to get a positive answer. If the negative is larger, you're going to get a negative answer. It's strictly which one has more in the fight, essentially. So in this case, 8 plus negative 2, I'm just going to take 8 minus 2 because they're different signs, and I get 6. Well, for negative 8 plus 2, I do the same thing. I do 8 minus 2. I kind of do like higher positive if it was positive versus lower positive. So I just do 8 minus 2, which is 6, but then I have to know, oh, I forgot that the negatives have more of them. When it says two integers that vary in sign, what that's talking about is the same number, just one's positive and one's negative. And that would be like this example, 5 and negative 5. When I add those together, I should get 0. That's easy to do with the integer counters. There's the same amount, so they go against each other and there's nothing left. Or on the number line idea, I go forward and backwards, and it ends up being in the same location. So you need to know all of those rules, and if you know those rules really well, it should go fairly quickly, especially when we get to harder questions with decimals and fractions. Okay, on each slide, I've used the same numbers. I just put negative signs in different spots. I'm going to do the integer counter on one of the questions each time, but I'm not going to go into detail on each of those, just making sure that you understand the general rules. These questions you should know. These are all just adding two positives. So the rule is when I add positives, I add them up, and it's positive. Okay, there's 3 and 5, that makes 8, or 16 here in this case, or 15 and 21 makes 36. I'm just adding them all together, find the answer. Now, if you can do that slide, you should be able to do this slide. In this question, it's negative 3 and negative 5, so that's 3 negative integer counters and 5 more. And that's just adding them up because they're the same group. So that would mean I take 3 and 5 together and I get 8, but it's negative. 6 and 10 together is 16, but it's negative. 15 and 21, it's negative. Now, I know some of you are going to say, well, wait, I thought two negatives made a positive. That's for multiplication. Addition, how could two negatives make a positive? That makes no sense. If that were true, let me know. Because I'd like to take you to the bank with me and say, I'd like to take out a bunch of money for a house, and that's a loan, so that's a negative. And I'd like to take out a bunch of money for a car, that's also another negative. And then, by the way, you owe me all of the money instead of me owing you long term. Okay, that's what you're saying. It doesn't make any sense. So two negatives, when you add them together, just are negative because they were both negatives to start with. The tricky ones are when it's one of each. Okay, so this first one says 6 plus negative 2. So you'll notice here I have 6 positives and 2 negatives. Okay, and the important thing here is that these have to kind of cancel each other out. So the 2 negatives will get rid of 2 of the positives. They're gone, and you're left with 4. Well, how do I get that? I take 6 minus 2. Or in this case, 14 minus 6. Or 15 minus 8. I do the larger minus the smaller. Not necessarily first minus second. Do larger minus smaller. Commutative property doesn't matter which order you put them. So I could have flip-flopped those and it's the same answer. So now when you're looking at these situations, what you want to make sure of is that all three of these answers are positive. And the reason for that, the bigger number is positive. So there's more positive integer counters versus negative integer counters. These questions are exactly the same, except that I switched to the negative. So if you look here, negative 6 plus 2 versus 6 plus negative 2. I just flip-flop the negatives. All that does is flip-flop the integer counters to be more negative integer counters and less positive, which means that the negatives are going to have more in the end, so my answer has to be a negative. But if you look, I do all the questions the same way. For example, this 8 plus negative 15. I'm going to treat it like higher minus lower, okay? And I put it in quotations because 8 is obviously higher than negative 15. But I'm just thinking about 15 and 8 as positive numbers. So I take 15 minus 8, which is 7. And then I have to know, oh, by the way, that should be negative. You need to be able to do all of these questions and explain them really well without the help of a calculator. I know it's tempting to always just use your calculator at this point. And it's really tough with all the different things you're learning right now. But you need to make sure that you know how to interact with these numbers and deal with these numbers without a calculator, That's the expectation, that you can explain them as well. All right, so here's all of your homework for today. You'll notice I have odds and evens in some of this because it's kind of the intro lesson. I put the odd answers in the back and the even answers on the next slide. I know it's kind of hard to see that here, but I put them on the next slide for you. For some of those even questions, you need to get into the habit of the original problem. So for example, your work should look just like this. Like if this was a question, this top right one, if it was -6 or -14 plus 6 equals -8, you should have that written down. It should not just show -8. That's not going to help me. You can check that in the back of the book. That doesn't help me with anything. I want you to start getting into this habit. Original problem equals answer. Every math teacher after this is going to expect you to do that, so make sure that you do that. All right, so remember, it's from the exercises in section 1.2, numbers 8 through 15, 50 through 54, kind of a lighter load today. We're going to kind of go to this back and forth. Intro lesson with more understanding. The second one will be more like, here's the math, let's do the questions. Probably a little bit more homework, but you'll have probably a little bit more time to work with it. Okay, so we're going to go back and forth with those scenarios. If you have any questions, let me know. Have a good day, everybody.